We're going to divide a long division problem with just numbers because a lot of people don't realize that long division actually consists of 4 steps and only one of those steps is division. So we're going to start by dividing 21 into 8675309. And you guys should be pleased because I didn't sing it like that for any of the classes I taught today. So the first step, of course, is the actual division step. So we're going to take our divisor, 21, and we're going to divide it into the 86. And it goes in 4 times. But then there's 3 more steps to do, and none of them are division. Next, we're going to take that 4, the digit we just created from our quotient, and we're going to multiply by the divisor, 21, and we're going to write our answer underneath the 86 that we divided into. And then the third step is to subtract. And we get 2. And then the fourth step is to carry down. Some teachers teach it to where you only carry down just the next digit, that's 7. But you can always carry down all of the digits. You're going to ignore most of them anyway. And with a polynomial, it's incredibly easy to lose track of which digits you have carried down and which ones have just combined with something to become something else. So I would suggest that you just carry down all of the digits. And so then we would just repeat that cycle over and over until we generate our answer. So now 21 goes into 27 one time. Multiply, subtract, and then carry down. Okay, so keep that cycle going. I want you guys to pause the video, keep that cycle going, and see if you can generate the correct quotient and remainder. Okay, so pause it for just a sec. Okay, you should have paused, and what you should have come up with is 413,109 as your quotient with a remainder of 20. And so there are 2 ways that you guys have written your answers before. There's a third way that we're going to write your answer, which we would never write it as our answer for a division problem, but we would use it to check our answer from a division problem. And so we'll talk about that third way in just a second. So the 2 primary ways that you list your answers from a division problem are literally just, one of them is a list, like fill in the blank kind of thing. You're going to list your quotient, 413,109, and list your remainder of 20. The second is mixed number format. And everybody knows what mixed number format is. They just don't always recall the name of it. So when I tell them to write things in mixed number format, they want to know what I'm talking about. So if I said what is 5 divided by 2, the mixed number form of that answer is 2 and a half. There's a whole part and a fractional part, so it's a mix of 2 different kinds of numbers. Okay, that's the mixed number format. So for this problem, our mixed number would be 413,109 and 20 21sts. We write our remainder over our divisor. And then the third way that we write our answer would be essentially a way of checking our work. What we would do is let's say I hypothetically said, okay, I don't know what number I divided by, but I know I divided by 21, and I know that I got a quotient of this, and I got a remainder of this. What number was it? Okay, and so what this is a way that we could check our answer and make sure that we got 8675309 back. And so the way that I'm about to write it might make more sense if I looked at that other number up here. If I did not know that this was a 5 right here, then to go from this form to this form, what I would do is I would take these 2 numbers right here and I would multiply them together, and then I would add the remainder. And so that's what we do, is we take our divisor, we multiply it by our quotient, and then we add our remainder. So if I was trying to get my original number back, what I would do is I would take the 21 that I divided by, I would multiply it by 413,109, which was the quotient, or the number of whole times that it went in, and then I would add my remainder of 20. And I would hope that I would get 8675309 back, which proved I did the math correctly. Okay, and most of the time we're only going to use this to check our answers, because remember, we're going to be dealing with equations, and we want to be able to generate our original equation from things. So now we're going to try that process with polynomials. The process is the same. It's got the same 4 steps in it. The only tiny little difference is that we're going to do the division step a slightly different way. Okay, so I'm going to set this up. I'm going to do x squared minus 1, and I'm going to divide it into 3x to the 4th plus 0x cubed minus 4x squared plus 2x minus 1. Okay, and I'm going to start with the division step just like before. But one thing, the only place where this differs is when we did the division step with this problem, we used the entire 21. We took all of 21 and we divided it into 86. We didn't just take the 2 and divide it into something. That's the one thing that's going to be different about polynomials. When we do division of polynomials, we take just the leading term and divide it into the first term here. That's it. Those are the only things that we do that determine the division step. Okay, so I'm going to divide x squared into 3x to the 4th. Now, one thing you can do, if you have trouble doing division of polynomials, you can always rephrase it as a question to yourselves instead. And so what you can ask yourself is what would I have to multiply x squared by to make it become 3x to the 4th? And that will give you the answer to the division problem. I mean, it's really similar to saying, instead of saying, what is 8 divided by 2? You could just ask yourself, 2 times what is 8? It's the same thing. It's just rephrasing the question. So what you would have to multiply x squared by to make it become 3x to the 4th is 3x squared. So that's the first step, the division step. Once you're done with the division step, you go back to using the whole divisor. It's just the division step, just that first step in the cycle where you just use the leading term. So now that I'm done with that division step for now, I'm going to use my whole divisor. So I'm going to take that 3x squared that's out on top and multiply it by the whole divisor, and I'm going to write it underneath, just like I just did with the numbers. So 3x squared times x squared is 3x to the 4th, and then 3x squared times negative 1 is negative 3x squared. And then I'm going to take that and I'm going to subtract it. Now you've got to be really careful about that subtraction step. The subtraction is the most likely place where people make mistakes. So you've got to be really careful, because what happens is that people forget that this minus sign right here has to distribute to everything in that row. Everything's got to be subtracted. So you've got to do 3x to the 4th minus 3x to the 4th. Those cancel. 0x cubed minus nothing, so there's nothing there. I don't know how I just shrunk it, but then you've got to do minus 4x squared, and you've got to subtract the minus 3x squared, which is going to make it become a plus. So negative 4x squared, this just became a plus 3x squared, so you just get negative 1x squared. Okay, then you carry down the rest, the plus 2x and the minus 1. And now we repeat the process. So we're going to do the division step. So that means we go back to using just our leading term, and we divide x squared into negative x squared right there. And so if you need to, rephrase that. What would you have to multiply x squared by to make it become negative x squared? And you would say negative 1. Okay, so now that you're done with that step, you go back to using the whole divisor. So negative 1 times x squared is negative x squared. Negative 1 times negative 1 is positive 1. And then we take that whole row and subtract it. And so this is going to become a plus right here, so the x squareds will cancel. We have a 2x minus nothing, so it's just 2x. And then we have a minus 1 up here, but we're going to subtract another one, so we get a minus 2. Okay? So that is our remainder. And the reason I know that's my remainder is because 2x won't let x squared divide into it. This has a smaller degree than this, so it won't divide in. So the two ways I'm going to write my answer, I've got my list format. My quotient is what's on top still, 3x squared minus 1. And my remainder is 2x minus 2. Now the mixed number form needs a little bit of a change. Mixed number form, here's my whole part, and then I'm supposed to write my remainder over my divisor. If I only write it like this, it doesn't read the same way as if it was numerical. Okay, remember when I did 5 divided by 2 and I said it was 2 and a half? That and that is an invisible plus sign in between here. It's not 2 times 1/2, it's 2 plus 1/2. Well, with polynomials, if we don't put that plus right there, it's going to read as multiplication. It's going to think that the 1 is multiplying to the fraction. So you've got to remember to put that plus right there, or it reads completely differently and it's wrong. Okay? So now I want you guys to pause it once again, and I want you to try this one for yourself, and then unpause it and simply check your answer, and then you're done with the notes. Okay, let's see how you guys did. Your quotient should have been negative x squared minus 3x minus 15, and your remainder should have been negative 25x minus 72. And so as a mixed number, that would have been negative x squared minus 3x minus 15 and negative 25x minus 72 over x squared minus x minus 4. If your numbers differed anywhere, the first thing you want to do is you want to go back and check your subtraction steps, and you want to make sure you distributed the subtraction through. You can go to the Binder website, and you can look at the completed notes. They're online already, and check the actual numbers in the problem, or you can come see one of us for tutoring, and we'd be glad to look over your work and see if we could find your mistake for you. So hopefully you guys remember this from last year, and hopefully you guys are feeling pretty good about it. Remember, this is not on next week's test. This is the first day of the next unit. We just had a spare day before we review for our first polynomial test. Have a good 3-day weekend.